Welcome to the next lesson in the Pragmatic REST APIs course, where we will be talking about exception handling. Let's jump straight into the code because I have some interesting things to show you. Let's begin from the tags controller, where I'm going to place a breakpoint right here, and we're going to hit this breakpoint if we attempt to create a tag with a name that is already taken. So we have broken our uniqueness rule and we should return a 409 conflict response. So let me start the application and I'll send a post request to my REST API to create a new tag with the name of .NET. Now, a tag with this name already exists. So if I send this request, you will see that I hit the breakpoint and I should return a 409 conflict response. But let's assume that we encountered a race condition and I somehow managed to get past this check, but a concurrent request already completes and writes the .NET tag into the database. So if I hit continue, we're going to run into an exception because we have a unique constraint inside of our database. And if I press continue again, we will land back in Postman, where we can see that we got back a 500 internal server error. The response is a problem details object that contains some information about the exception that we ran into. Now the question is, do we even want to expose this information back to our client? Why does the client need to know that we ran into a database update exception? We're going to discuss this more in a moment, but let's try to understand how we even got to getting back a problem details response. In the previous lesson, I added some customization to the problem details services. One of those changes was adding the request ID to my problem details response. But let's say I comment this out and restart the application. I will send the same request again to my API, and as before, I land on the breakpoint. Now I'm going to mimic a race condition and press continue. We get an exception. And if we take a look at what we get back in Postman, this time the response is a bit different. We are getting the entire exception message, including the stack trace, returned back to the client. So you can see how exposing so much information back to the client can definitely be a problem and even potentially a security issue. So let's revert back to change and bring back our problem details customization. And this already solves part of the problem. With this, we are only exposing some partial information about the exception and also some diagnostic details. Looking back at the original error response, I want to take the trace ID from the response that I get back, and inside of the Aspire dashboard or Seek, I can use it to filter based on the trace ID value. So now this allows me to find all of the structured logs for this specific request. And you can see that we already have some pretty detailed logging present here, starting from the point where the request reaches our API all the way down to the unhandled exception. If I click the exception details icon, I can go ahead and see the complete stack trace, and this can be very useful for debugging. So we already have a lot of the built-in exception handling present inside of ASP.NET Core with very minimal work. However, I want to improve on this even more and omit the unnecessary information from the client response. So let me show you how I'm going to do this. I'm going to use the built-in exception handling middleware by introducing it to the request pipeline. I need to say use exception handler, and this will introduce the respective middleware. Then I'm going to create another folder inside of my API project. Let's call it middleware, and inside of it I'm going to add a new class that I will call the global exception handler. This can be a public sealed type, and I could define this as a middleware, but there's a simpler abstraction available in ASP.NET Core called the iExceptionHandler. This is going to run as part of the built-in exception handling middleware that I just defined, and it acts like a chain of responsibility pattern where multiple exception handlers are going to trigger and try to execute the try-handle async method. So how can I use this to write my response? I'm going to inject the problem details service, which is also available in ASP.NET Core, and you may notice that the try-handle async method expects a Boolean result. So what you can do is use the try-write-async method on the problem detail service. There's a pretty nice match between these two abstractions. Now this accepts a problem details context instance, which does have some required properties. One of those is the HTTP context that we can specify based on the available arguments. We can also pass in the exception, and then I have an option to customize the problem details response. For example, here I may want to set a few of the properties and not all of them. Let's, for example, set the title, and the title can be internal server error. If I want to expose more detail to the client, I can say something like an error occurred while processing your request. Please try again. You can customize this however you want, and then how you actually use the global exception handler is by adding it as a service. So let's say after I have added my problem details, I say builder services add exception handler, and I specify my global exception handler implementation. So now when I run the application and I attempt to create an invalid tag, and I again mimic a race condition and run into an exception and press continue, you will see that we're going to land inside of the global exception handler. Here we're going to use the problem detail service to try to write a response, which we can customize based on our requirements. So now if I press continue, we're going to get back the response in Postman. It will be a 500 internal server error, and it's going to contain the title that we specified, as well as the detail that I specified when customizing the problem details. The other properties are going to have their default values, like the type, the trace identifier, and the request ID, and this is how you can manage unhandled exceptions, return a problem details response back to the client, while hiding any sensitive information from the response itself. The logging is still going to work as expected behind the scenes, so we still have access to the structured logs containing our exception details. We can also use this approach to implement another exception handler, for example, for handling validation exceptions. Let me show you what that could look like. I'll add a validation exception handler type, and let's implement it. I need to implement the iExceptionHandler interface, which exposes just one method, and I'm going to use the iProblemDetail service to write my problem details response. Now, because I want to handle only validation exceptions, and to be more specific, I want to handle validation exceptions from the Fluent validation namespace, I can say at the start of the tryHandle method, if the exception is a Fluent validation exception, then I want to continue my logic. Otherwise, I can say if it's not, then I'm free to leave this validator by returning false. Now I'm going to make this async, and we're going to return await problem detail service try write async. Now I just need my problem details context. So let's go ahead and create it. I'll initialize a new problem details context instance, and we're going to pass this to our try write async method. Now let's focus on what we need to set here. We need to pass in the HTTP context, the exception, and I want to initialize the problem details so that I can customize it. For example, I can set the detail and say that one or more validation errors occurred. I also want to set the status code to a bad request. So I'm going to say status codes 400 bad request. Now, what about the actual validation errors? Well, we can pick those up from the validation exception, which I can grab here after my pattern match. Now I can use the validation exception to access the validation failures which are present in the errors property, group them by the property name, and then convert them into a dictionary. After I do this, I can append them to the problem details. In the extensions dictionary, I can say add, specify the errors, and pass in the errors value. Now, one more thing that we should do here is update the status code of the response. So I'm going to say HTTP context response status code is 400 bad request, because I wanted to match the value that will be returned on the problem details response. Now, how do we enable this validator? Well, we just have to include it before the global exception handler. They will run in the order that they are registered in. So if I first register the validation exception handler, it's going to run before the global exception handler. Now, when it comes to throwing the exception, let's go to the habits controller, and inside of our create habit endpoint, I can replace this call here that was returning a validation result and a bad request response with just a call to validate and throw async. Now this is going to throw a validation exception that my validation exception handler will pick up and convert into a problem details response. So if I send an invalid request for creating a habit to my API, you will see that we run into an exception from our validator, and if I press continue, we're going to land in our validation exception handler that we just implemented, which is going to handle this specific exception and convert that into a problem details response. And this is what we get back on the client. It's a problem details object. The response status code is 400 bad request. We're saying that one or more validation errors occurred. And then in the errors property, we have the specific values for the specific validators that have raised an error. The client can figure out how to respond to this based on the response. Maybe they want to show some errors on the user interface based on the messages that we got here. But still, the main audience for reporting errors like this is other developers integrating with your API. For example, if I'm not familiar how to integrate with the DevHabit API and I get back a 400 bad request, I can observe the errors collection and figure out what are the problems that are preventing me from creating a new habit. After I solve all of them, I can send another request which is going to succeed, and I end up creating a new resource. All in all, you don't need to do a lot of additional work to implement some very robust error handling in your APIs. ASP.NET Core already has many things built in, like the global exception handler, which allows you to chain specific exception handlers to implement some custom exception handling logic if you need it. The default exception handling logic is also pretty good, and what's more important is you will also have built-in logging of the exceptions inside of your structured logs. I also showed you how you could simplify the validation responses. Instead of returning a custom problem details instance like we have here, you could throw a validation exception that you handle globally with something like a validation exception handler, which you can easily convert into a problem details response. In this lesson, I gave you a couple of practical options for how you can approach exception handling in your REST API. The only option that I didn't cover was creating a custom middleware. I expect that this is something that you have probably seen before, so I didn't want to focus as much on that approach. We will be talking about custom middleware in one of our upcoming lessons, but more on that later. What I did want to show you was how to use the exception handler abstraction and the problem details services to standardize your API responses. In our upcoming lessons, we're going to be dealing with advanced querying support for our REST API, and we're going to start by implementing searching and filtering.